This video will discuss the scientific method, which is an organized way to explain observed phenomena, observed things that we see in nature, and it is a way to understand them, to quantify them, to develop equations that will describe how that phenomenon occurs, and to ultimately result in a scientific discipline or a scientific area. The reason why I'm discussing the scientific method is because we will apply the scientific method to a number of scientific areas. The predominant one will be evolution theory, to see just where evolution theory stands in the scientific method, whether evolution theory has already arrived at the point of being a science or whether it is still a scientific theory waiting for proof. We will also see the scientific method applied to several other scientific areas that are needed or need to apply that to it so that you can develop an understanding of things like Big Bang theory, evolution theory, and some of the genetics type things, so that you can understand the application of those sciences to biblical creation. In any event, this video will discuss the scientific method. Now, the scientific method consists of 5 steps. It is something that has evolved over centuries by various scientists attempting to explain things and then developing these 5 steps that pretty well enable one to have a rigorous, organized way to look at a phenomenon that you're interested in explaining. So it starts with, first of all, of course, the observation of a phenomena. Something happens in nature. We see perhaps multiple examples of it that look kind of similar. We then develop a theory that explains it, use existing scientific laws perhaps and or modifications of them to explain what that phenomenon, how that phenomenon occurred. And then we compare all that current easily obtainable data that we have in that area to make sure that the theory we've developed agrees with the data that we have in hand. Those are the first 3 steps. And at that point, one has a scientific theory. Not a science, not a scientific law, but a scientific theory. What needs to be done after that theory is in hand is to make predictions with it outside of the current range of data, to see whether the theory that you develop in its initial form can make predictions for some other sets of conditions, for example, and then we perform tests to see whether those predictions are indeed true. If they are true, and we've made all kinds of predictions of our theory and all of them seem to be proven, then we end up not only with a science, but we end up with a scientific law, perhaps, if it's a general enough thing that we're trying to explain. If we don't have success in step 5, and our predictions are not validated by the test, then we need to go cyclically through steps 2 through 5 and modify and change and do more testing until we end up explaining all the data that we have predicted should occur in a given set of phenomena. Now, this sounds like something only scientists do, but in reality it's something that virtually all of you have done at one time or another in your daily lives. For example, you might have observed a puddle of water somewhere in the carpeted living room, let's say, and that puddle of water is in a corner, and you come upon it and you see that, oh my goodness, this carpet is wet out to 2 or 3 feet from the corner, and I wonder what's going on. Well, in your mind you develop a theory. Number 1, is there possibly a water pipe in the wall that's leaking, and that's why I have this leak? Is there a leak in the ceiling, perhaps, in the shingles on the roof of the house that's leaking through there? Or if you live in a place where you have air conditioning units up in the attic, is it the drain pan, the auxiliary drain pan from the air conditioning unit that has overflowing, is leaking down the wall and coming to this point? Well, with these various theories, you can test it out. You can go and turn off the water to the house and see if that puddle is increasing in size or if it's stopped increasing. If it, say, had been increasing and when you turn the water off it's still increasing, then that's obviously is not the source of some pipe that's broken behind the wall that's leaking when it's under pressure from the water system. The second thing you might do is turn off the air conditioning unit to see whether if I stop making water taking water out of the air that I'm air conditioning for my house, does the puddle stop growing? In that instance, if the puddle stops growing and you have turned the air conditioner off, then you have validated your theory that it was the air conditioner drain pan that was causing my water to leak, and you go about repairing that side of things. That's just a simple example, and in everyday life you can probably think of things where if something strange happens and you develop a theory, and then you develop a test of that theory and go out and see whether or not what you saw was explained by the theory you developed. But in any event, scientists do this on a daily basis as they go about investigating phenomenon, whether in industrial research, academic research, or whatever. Now, one of the things about the scientific method is it needs to be done in a rigorous and honest way. We like to believe that all of our scientists are honest, that they tell us about various things that are happening in the world, and we inherently do trust them. But what two icons here have demonstrated to us, or pointed out to us more correctly, I guess, is that it's possible for these scientific pursuits to go askew in some way. And the first of these was Socrates. Socrates pointed out that one, in pursuing scientific results or any kind of academic pursuits, you need to follow the evidence wherever it may lead. It's only human nature for us to develop some idea and then to look for data that only support this idea we have in our mind. But a scientist has to resist that and has to follow the data wherever it may lead. In the example I just gave you on the prior slide, if you make some prediction and that prediction is outside of the theory that you've developed, you need to modify your theory. You need to have an open mind to be able to include evidence that you see in your theory and have the ultimate theory explain everything that you see, not just that you want it to explain. Richard Feynman, the Caltech physicist, added yet another caution here, a little more personal, I guess you might say, and he said, you must never fool yourself, and you are the easiest person for you to fool. He's basically saying that you need to be on guard to never fool yourself in what you're doing in the scientific area, and unfortunately, you are the person who can most easily fool yourself. Again, with looking into in intimate detail into some area of technology, it's very easy to reach the point where you are so immersed in it that you will see only data that support what you think is going on, as opposed to data that fall outside of what you're doing. But you need to be careful about that. Now, a very interesting example of this is Professor Anthony Flew. Professor Flew was until he passed away, I believe, in 2011, had been a professor of philosophy at Oxford University. In fact, he was there during the time when C.S. Lewis, the writer, was also there, and the two of them often debated at the Socratic Society at the university, in which C.S. Lewis would present some Christian aspect of something that they were discussing, whereas Professor Flew would present the atheistic viewpoint and would attempt to explain whatever they were talking about in terms of atheism with no need for any kind of a supreme being or God to be involved. Now, as by Professor Flew's own account, for over 60 years, he was, and he believed he was, and the world acknowledged that he was the #1 atheist in the world. He wrote 57 books, and the first 56 of those books were covering atheistic perspectives, atheistic arguments for why the supreme being or God was not needed to explain all the various aspects of the world as we see it. He wrote the 57th book, and much to the chagrin of fellow atheists, it had this title, There Is a God. He crossed out the no and put an A in there in his title, that there is a God. He became, I believe, at least a deist, someone who believed that there needed to be a supreme being, a God, to explain the world that we see. He came to this conclusion in his own autobiography. He explained the fact that his contact with some cell biologists, I believe at the university, cell biologists who demonstrated him the complex behavior of living cells, he realized that it was not possible for that to have evolved slowly over time. It was so beautiful and extremely complex that it had to have an ultimate designer in order to make that system work. And so that's how he was converted to at least a deist, to believe that a supreme being or a designer needed to be involved in, at least in the human cell. And you'll see in other videos that not only that, but there are other aspects that are convincing for a person who believes that there's no design needed in various aspects of living. So here is the scientific theory again, where in a little bit more detail, where we see the first three steps are observation, development of a theory, and comparison, and that is known in the scientific world, mathematical world, as a correlation. If you reach that point, you've got some equations that pretty well explain what you've observed, you have developed a correlation. And it's quite a different thing to develop a science. You need to go through all of these 5 steps, make the predictions, and perform the test and validate that those predictions are true. That then becomes as an application of a scientific theory, and going through all 5 steps leads to a science, an area that we would call a science, as opposed to something that is only a scientific theory. In conclusion, for the scientific method, you have seen that every potential theoretical science must satisfy all 5 steps. That's the crucial thing, that in order to be really called a science, not just a scientific theory, one needs to complete all 5 of those steps. If you complete only the first 3, you are a correlation. You are not a science. And we're going to see later on, you may have from the inkling that you've seen if you watch the initial introductory video and seen the title of the book, you're going to see that what I will demonstrate to you is that evolution theory is at this point only a correlation. It has completed the first 3 steps, but there's absolutely no proof for it. In any event, this concludes the discussion of the scientific method. I hope you will go on to the remaining videos in this series to see the application of it to other areas that will help you understand why I believe that evolution is not true and that biblical creation history is the best explanation for life on earth.